Hello, happy time zone. Hi Thor. Hello, happy time zone. We're gonna be going and we're gonna keep going with the thing that we were doing yesterday. And hey, guess what? I actually got stuff. That's the wrong outfit. Hang on a second. Uh, I actually got stuff working. Let me get some music going here. I got stuff working last night. Last evening, whatever. I don't know. I did a little tiny bit of work off stream, is what I'm trying to say there. And I actually I got a GIF. I got a GIF exported I got a GIF converted to a PNG, which is kind of a little proof of concept there. But that means the image loaded. It actually loaded as an image in Jodot. And the result of that is actually right here. Brace for escape velocity, now it's time to go. As you can see, it is red because we're only exporting one channel. This is actually the index channel just being outputted as a red value because we haven't actually started mapping it to the correct index yet. That's super easy to do though. Thankfully, when the GNU image manipulation program exported this for us, it sorted the colors by their luminosity, and so what we end up with is essentially a grayscale version of it. In this, it could have looked all like messed up and stuff. So if we open this in the GNU image manipulation program, it's all set, just me and you. Brace for escape velocity, now it's time to go. You can see that up here we got all of the darker colors are earlier in the palette, and all the lighter colors are later in the palette. So the palette's been sorted for us. That is not a technical limitation, that's just something the GNU image manipulation program did for us when we converted to a palette. Anyway, so there were two things that were happening. One, we needed to expand the table size at very specific intervals. How are you doing today? I just woke up, so I'm all right. I'm still kicking. Anyway, this code is an absolute disaster, but, and it's going to look a lot smaller once we get rid of all the logging stuff. But yeah, there's a thing, this predicted table index. So what GIF does that LZW doesn't do on its own, LZW compression works on codes. Codes are a little bit ambiguous in LZW. In GIF, codes are just bits in a file. And we load codes one at a time, but the codes are a variable size, and the size of the code changes as the table expands. We have no information about when that table expands, except for the rules that cover its expansion. Hey, Mnemonic, how's it going? So, basically, we have this predicted table index, which is where we're adding codes to the table. And once the table gets to the point where the codes start becoming bigger than the number of bits in this minimum code size thing, then actually, wait a minute, is this wrong? Yeah, because we increment before we actually read the... No, we don't. Okay, there's a few, like, off by one weirdnesses here, but basically, yeah, we have this predicted table index, which is where in the table that we think we're at. And because when we're actually doing the decoding, every single time we do a decoding step, we actually add something to the table every single time. And so basically we know that while we're decoding, trying to get these codes out of the bit stream, we know that every time we do want to like decode one of the codes, we need to increment that table position. So the table starts off, for a 256 color image, we'll start off with indexes 0 through 255 filled with just a one-to-one mapping between 0 to 255 maps to 0 to 255. And then after that we have the clear code, which is at 256, and then we have the end of data code, which is at 257. So from the very beginning, we need to have 9-bit codes, right? Because otherwise we wouldn't be able to fit the 256 and 257. We'd only be able to fit the 0 to 255. So we're starting off by reading 9 bits at a time. And again, this is for the 256 color example, which is like the one that everyone knows about GIFs being 256 color. And so it's the one that keeps getting repeated in all of the documentation and stuff. So yeah, we're reading 9 bits at a time. Eventually, we're going to reach the point where the table is up to 512 codes, right? And once we hit that point, we're going to need more than 9 bits for the next code. That's the point that we expand the table size, and that's the point where we start reading 10 bits instead of 9 bits every time. So yeah. Basically, we need to know when we need to start reading a different number of bits from the table. So the LZW minimum code size does not take into consideration the end of table and clear codes, which is why we're always reading the LZW current code size plus 1. Now, I'm gonna make sure that I actually like committed this code before we go and mess with it. Yep, we're good. And if we run this, it basically just it overflows the output. You can actually see the image data in this text. Like when I saw it and I saw like the actual like arrangement of indexes, it's like I know that's valid image data. And then what we got out of it was, you know, again, this, right? We don't have to match that up to the actual indices to know that that's actually correct, because we can tell. We could actually like map it to the actual indices, but I gotta do a little bit of plumbing first. And we're still working on this low-level nonsense, so. Yeah, baby. Shelly, do you wanna hop on this next one? I don't even see the code anymore. Okay, look, you know what? Learn to read binary and like convert it to ASCII in your head. And you won't see the numbers anymore either. Trust me. I was actually doing flashcards for that at one point. I wonder if I still have the Anki cards up for this. Yeah, so I got these ASCII cards, like flashcards that I was trying to memorize. Latin capital letter C. You get the hexadecimal, decimal, binary, and all that. What if it's Unicode encoded as UTF-8? Does not matter, because if you are an English speaker like me, then only the first 256 characters matter. Oh, only the first. How many actual visible characters are there in ASCII? Not that many. It's less than 256. It's like 256 minus 32-ish. 224-ish characters. If we do like man ASCII, ASCII. You can see that the actual like visible characters start at hex 21 or number 33, and they go up to almost the end. So it's like 223 characters. Only these ones actually matter. These show up exactly the same in UTF-8 as they do in ASCII. However, there's also a good way to recognize UTF-8, and if the first bit is set, then it's one of those other characters, right? I speak 4 languages. Oh, aren't you fancy? Anyway, but if you're reading, like, if you see code, like if you see a bunch of code fly by on a screen that looks like binary numbers, because people use binary numbers to make things look high tech all the time, you'll notice a pattern a lot of the time. You'll notice a lot of patterns that look like hang on a second. I don't know if I want to restore this data. Oh, yeah, okay, that's just the data from yesterday. Yeah, you'll notice a lot of patterns that look like 0, 1, 0, and then just the rest is like that, right? And this is a lowercase letter. Yeah, this right here is a lowercase letter. This is an uppercase letter, generally speaking. There's like symbols in there also and stuff. 32 to 126. Yeah. Right, I got the number wrong. Yeah, you're right. I accidentally included the entire 256 when it should have been 126 minus 32. Okay, 94 visible characters. Yeah, so basically, if you see something that follows this pattern, then it's outside of the ASCII range. Anything that starts with a 1 outside of ASCII, because it's past 127, and it's one of those fancy UTF-8 characters, or it's extended ASCII, which no one does code page 437 anymore, except for, like, hackers. Thank you for the hydrate. Hackers when they're writing their info files. But anyway... So you tend to recognize these patterns a lot, where it'll be like, you'll see like a string of numbers that looks like this, and it's like capital letter, lowercase. Wait, no. Hold on, I got it the wrong way around. It's actually lowercase. So actually, is that it? Hang on a second. Might be getting all of my numbers actually wrong here. So if you look at the difference between like capital A and lowercase a, it's 42 versus 41 versus 61. 41 minus 61 is in hex equals 20. Well, 61 minus 41. Let's do that. Is 20. So if you look at like hex 20, or what that is in binary, that is that. Okay, so actually what we're looking at is yeah, no, that was right. Okay, yeah, so this is the lowercase bit. Bits 5 to 7 are column selectors, and 1 to 4 is the character selector in the column. Column selectors. Is that what some DOS games are written in? What, ASCII? I mean, yeah, I think DOS games... Well, DOS games in the US and English-speaking worlds generally would use ASCII as their text encoding. So yeah, this is a lowercase bit. So a lot of the time you'll see something like this, and it's like, you'll note this is an uppercase letter, and these are lowercase. And then occasionally you'll see this. That's a space. So you'll see like strings of characters that look like this. You can tell visually this is ASCII, because it's like uppercase letter, lowercase, 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 space, lowercase, 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 you know? Link a table on Wikipedia. It'll make sense. That does not look easier to to memorize for me. Or is it this one that you were talking about? The first one? This one? Yeah, no, that's harder. I'm sorry. Anyway, all I'm saying is that it's really easier to recognize ASCII code when you see it. If you watch like a sci-fi movie and there's a screen with a bunch of binary numbers on it for some reason, then you know that it's probably, you can tell if it's ASCII or not. Similarly, if you see a bunch of hex numbers or hexadecimal numbers and they're all like 20 and above, and but like 7F and below, or 7E and below, then you know that it's ASCII also. Anyway, what's learning this for? For funsies. We're actually writing a GIF format loader though, from scratch. And so we're dealing with a lot of binary numbers and stuff. A lot of binary numbers that don't come in nice, even intervals. Okay, so we have to change up this. This has like an offset. So we got the LZW minimum code size, and so the predicted table index is actually going to be, Also, we got a problem right here. This is not implemented. We need to get the math right up here before we can get the math right down here. So I'm going to say... Yeah, so LZW current minimum code size, or current code size, is going to match the LZW minimum code size, which is the one that we read from the thing. I'm going to say that's going to be +1, because if we read an 8, we actually need to read 9 bits to account for the clear code and end of data. Thank you for adding depth to the stream. That is... Ow! So yeah, that's going to account for that. The predicted table index, though, is going to start off at the LZW minimum code... oh wait, that is minimum code size. And that's going to be +2. Because we're going to account for, again, the end of... the end of data and the clear code, right? Okay, so in that case, we're actually going to get the number of bits in the LZW current code size, because now it's actually been adjusted, so it's the actual current code size. And though allegiance sides with me and marches on ferociously, can't force war to find my peace. I see the other side, one world beyond our dog pride. Somewhere outside is evolution standing by. Amassed in crowds, you're still alone. The last of one with the mind of its own. Okay, we're going to get rid of this, adjust that back down, and then we are going to... Hey! Is he what I hate so in myself? Vanquish this from me. Despite my open mind, I cannot force those who are blind. Putting up their eyes and saying, I claim no one, just victory. That missed? No, that didn't miss. That smacked me right in the head. It just didn't stick. To see through the shroud of destiny. Time and law are both my enemy. Okay, so I think I have everything adjusted to kind of compensate for the fact that we're now using current code size as the actual current code size. And this is probably going to break, because, I don't know, it just always breaks. Yep, there we go. Out of bounds, get index 530 in base dictionary. Alright, what did we do? So we reduced it there, and we, you know what? I know a different way to do this. I'm going to check out this. See, this is why I did the thing there. Turned away, around to hide. I have lived with my own mind as my guide. This is not current code size. Yeah, this is not reflecting the oh. It's in my mind. It's just drive me blind. All right, I'm gonna restart the editor. Game Maker. Why don't you use? You should check out Jodot. I like Jodot. 1 in a million's just a drone. Amassed in crowds, you're still alone. The last of its kind is the one with the mind of its own. Wait, is this code size? Oh wait, no, that is the correct thing. Okay, cool. 1 in a million's just a drone. How, like, everywhere that we use LCW current code size, we're just gonna add 1 here and then subtract 1 at the other one, okay? That's all we're gonna do. So we're gonna do +1. We're gonna get rid of that +1 there. And then we're gonna go here, and it's gonna be that, and then we're not going to bother modifying it in the output. It's kind of the one with the mind of its own. I'm going to get rid of the +1 there. We're going to get rid of the +1 here. We're going to get rid of the no, we're not going to get rid of the +1 there. That needs to stay. The increment needs to stay. Okay, that should work. That should work, right? It does work. That's fine. Cool. Do we still have a successful output image? Yes. Yes, we do. We should actually, like, just slap this onto texture. Here, let's just throw together a quick scene. I'm using 3D scenes because that's I know 3D better than 2D. There we go. Got a mesh instance. We're gonna add a plane mesh. We're also going to add a camera 3D. We're going to back that up a little bit, rotate the plane mesh around. And then we are going to add a material, surface material override. Actually, wait. You know what? Never mind. This is too much work. This is too much setup. We'd have to like make a texture that has, or make a material that has, it takes a texture as a uniform buffer thing, and All right, fine. I'm a graphics programmer for a living. This is what I do. I can do this. We're gonna make a new material, new resource, material that just takes a texture. Except we're not gonna call it that. We're gonna call it a shader material. Shader material. Boop. Material that just takes texture.tres. And then inside of that, we're gonna make a shader. Let's see, new resource, shader. Never remember the type of the shader. Oh wait, there it's literally right there. Shader. Call it the same thing. Spatial shader, sure, whatever. If we run this scene, we will actually get a box. We got a box. It's awesome. Cool. Okay, so we're gonna hop into that material, say the shader is that shader, cool, and then we're gonna say a sampler 2D, do I have to put uniform, whatever, the texture, I think it's gonna be uniform sampler 2D, the texture, right? Yeah, there we go, okay. And then we're going to say emission equals texture, the texture, and we're going to just use these. And then it's going to fail because we're combining vec3 and vec4. RGB. There we go. Cool. And then all we got to do is set the parameter on that when we get to that point. Boop, 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 boop. We're gonna go all the way down here and say mesh instance 3D dot surface material override is going to be a shader material. Wait, no. It's going to be that shader material. Okay. Material override 0 dot so Joda also has 2D, you know. Set shader parameter, blah, and we're gonna set it to text. Text is a variable that does not exist yet because we have to make it. Var text, which is of type texture 2D, is gonna be out image dot create. No, wait, hold on. Texture 2D dot create. How do we make it? How do we make it? How do we make a texture from an image? Texture, blah 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 blah. Texture 2D image texture. It's gonna be an image texture. Image texture dot create from image. Okay. Image texture dot create from image out image. Yep, that ought to do it. Let's go. It failed. Invalid access to property or key 0 on base object of type null instance. The surface, it's get surface material override 0. Of course. Hey, look at that! It's actually displaying in the thing now. Nice. Let's make a world environment so we don't have to deal with any of the lighting. We're going to make a new environment, and I think by default, yeah, everything should be fine there. Now it's going to be dork, and no, it's not. Background. 0, 0. There we go. Perfect. Pitch black scene with an emissive material. And there we go. Now we can instantly preview our things. And we can probably go ahead and get rid of the the thing that actually saves it out. Also, this is happening in, like, happening in, like, totally the wrong place in the code, because this is happening in, also, it looks like it might be actually quite slow to load that stuff, so this is going to take some extra figuring out. But yeah, this is happening in the load image descriptor function, which is just that's gonna be something that actually like modifies an existing image. So we're not all of this stuff where we're like generating the image here. This is all temporary crap. Fix me temporary stuff for previewing while developing. Bam. I bet if we got rid of some of the debug output code, it would actually be fine. Maybe. GDScript might just be really slow for this. Oh, okay, that's pretty fast. All right, that's good. Nice. Okay, let's go ahead and... Oh. Let's go ahead and commit what we have. Get status, get commit. Oh wait, hold on. We gotta add things. Boop, boop, boop. So let's get commit dash a dash m. Stuff. That is the first actual text, legible text that I've had in my commit messages. If you look at the log, we got and we got and now we have stuff. Yeah. Cool. I am good at writing commit messages. Don't judge me. You can judge a little. It's fine. Okay. Where were we? Fix me. There's a special gift case that we aren't handling yet. Why who wrote this comment that we, oh god. Oh wait, no, we are handling it. We are now handling it. That is done. Okay. Let's go back up here. We gotta now handle adjusting the wait. No, not there. Wait, yeah, up there. Wait, no, hold on. Right, we gotta handle the clear codes, if we get clear codes. Hello, Sleepy Tail Coder. Unfortunately, I don't know if we have any examples of GIFs that have clear codes in the middle of the data, which is something that we do need to be able to handle, but I don't... Let me see if I can find that on the internet. GIF with clear codes, extra clear codes. That is, oh my god, if you search for GIFs, you just come up with a bunch of images. Ow. We also need to handle this in a way that doesn't mess up the existing like clear code thing. Because we do get one clear code that we handle that correctly, and then we move on and we keep. But this is going to actually notice when we get that now, and we have to make sure that things end up at the right position. So let's see. Actually, we'll just do this. Print offset. So yeah, we're gonna reset that back to normal, and I think that's also fine. And then I'm gonna stick a breakpoint like right here. So if these are 0, then we're good to go. It is not 0. So yeah, the very first code that we get is a clear code. I kind of wonder if maybe we should just we should probably move the predicted table increment down below all of this stuff. Predicted table index increment, rather. Okay, offset LZW current code size 2. Also, I did screw that up. Okay, LZW current code size is actually, that's correct. We got the correct value there. And then this is going to be, predicted table index is going to be 1... And I think I screwed this one up too. Awesome. Hi, how's it going? All right, did we get that right? It's -2 now. Nice. Okay, that's predicted table index. Is predicted table index just gonna be the? That's not right. That's not good. What could be causing that? Predicted table index. It's gonna get predicted table. Oh, predicted table index actually starts at LZW minimum code size. That is also incorrect. We gotta name your heckin' layers. We're not doing an art stream right now, so we can't. There's no layers to name. Okay, so predicted table index starts at LZW minimum code size, but we actually need that to be at like LZW minimum code size +1. Actually, is this still loading the image successfully? Yes, it's still loading the image successfully. We got a bad window, invalid window parameter. Ooh, that's exciting. So yeah, for anyone who hasn't been here for the last couple of streams, we are working on gift decoding for funsies. Fun and something. So why is that when predicted table and we increment and then we check. So if predicted table index, interesting. Okay, predicted table index is actually going to start at like the 2 to the n, which is going to start pointing at the clear code. And then we increment it again, and then we do it. We do a greater than or equal comparison. So, yeah, I guess we could just do this. As long as these are the same, I think we'll probably be okay. Yeah. Alright, have a good lurk. Okay, so they are now 0. We'll go ahead and set those values to those. Let's say LZW... Wait. Yeah. LZW current code size is going to be LZW minimum code size +1, which is I think what we set it to up here. Yep. And then we say predicted table index is going to be, it's going to be that, which is the same thing that we set up here. And in theory, I think because we're basically setting it to the same thing that it was, we're still good. Now, the problem is we got to find some of those GIFs that have like midstream these things. The clear code clear codes in the middle of the stream. So where are we? Yeah, current bitstream byte index. Our code index and equals 0. Just for debugging. Industry assholes of America. Okay, if code index not equals 0. Oh, hey, we leveled up! Nice! Print, got a midstream clear code. Exclamation points. Nice. Let me go ahead and mount that that thing of GIFs. And I'm gonna go ahead and I'm gonna pull all the space GIFs out of it. Space. Oh, there's Star Wars GIFs. Oh, that's interesting. Should we just use Star Wars GIFs? That's kind of like space GIFs. I just want to quickly scan this for anything I can't show on screen. I wonder if any of these are animated, but they're just not working. One of these appears to depict C-3PO with the boner, and I'm not entirely sure. It's a little bit weird to look at. I don't know if that's actually an actual photo and the costume is just like shaped that way or what. I'm not gonna show that on stream. Oh, okay. The name of the GIF is c3naked.gif. So yeah, we are not gonna be showing that one on stream. It's just like a really weird Photoshop or something of it. That's neat. Oh, we got Star Trek GIFs also. Nice. Okay. Okay, some of these are kind of funny. Okay, good. We're good to go on the Star Trek directory. Based on what I saw in there. So yeah, we got a whole bunch of Star Trek gifts to get through. And this will be our test data set. Oh, is that? I wonder if that's actually 3D. Where's my glasses? Yeah. Oh yeah, that's got some depth to it, I think. Kind of hard to tell. Oh, gotta hydrate. Thank you. Alright. Though actually, does it actually have depth? I mean, these might all be at the same offset. It's really hard to tell. It seemed like it had depth. Apparently, Spock really likes the Amiga, I guess. That's cool. We got some Mirror Universe Spock. That's cool. That's a cool shot of a bird of prey. Borg. This stuff was all like this stuff was all like brand new at the time the CD was pressed. Because this is this show started or like TNG had only like just started, I think, at that point in the early 90s or late 80s. I don't remember exactly. Though then again, this is a later TNG like outfit design, right? We got this is the early TNG uniform from like season 1, and then they switched into this later on. Maybe after like I don't know if that was the first season or the third after the first season or after the second season. I think it was. Yeah, there we go. We got the season 1 silly looking collar. Got Earth Space Dock. Constitution class. Guinan and Geordi. Guinan in the past. Worf. You know how long it took to download each one of these individually? Look at like BBSs that let you download Star Trek GIFs. Isn't that wild? I don't even know what's going on there. Digitized by Event Horizons, and then we got some phone numbers for the BBS that isn't around anymore. Oh, we got some stuff about the Klingon D7s. Nice. Sorry, I'm just taking a break from writing the code. Oh, we got Christopher Lloyd as the bad guy from Star Trek 3. It's Doc from Back to the Future. Do you recognize him? Data's daughter. Make it so. Get it? Yeah. Okay. That's a nice art of McCoy. I'm wondering if some of these GIFs that aren't loading... Okay, I'm wondering if some of these GIFs that aren't loading are the ones that actually have the condition that we're looking for. Anyway. Card is a Borg. There's also some other situations that we're probably not... Oh, Renson Rowe. She's cool. Scotty, hell yeah. This is Spock from those like reunification episodes, I think. So this is some stuff that gets pretty late into TNG. Star Trek 5. We don't talk about Star Trek 5 in this household. We got the best Star Trek. We got Star Trek 6 here. Hell yeah! Look at that poster in all of its crunchy, delicious 256 colored glory. This is the best Star Trek movie in my opinion. I saw this in a theater, all right? I saw this in a theater. How old was I? I was 7, I think. The theater was packed too. All right. Anyway, we got stuff to use as test data. So I'm gonna take all of this stuff, and then we're gonna throw the thing at it. I'm gonna stick a breakpoint right here. We're gonna see if any of those gifts actually make this test case hit. I don't know how many of these are actually going to work. I think we got other errors in here that we're dealing with, that we have to deal with, to actually make these work. But in the meantime, let's go ahead and let's just pick a random one. Let's say this one. This one looks fine. Test Star Trek. We got a midstream player code. Hell yeah! Thank you so much for the follow, Mafito. How's it going? All right, it actually hit the condition that we were looking for. Awesome, first try. Very cool. Is that actually going to load the image? Doesn't look like it. Let's print the decompression result at the end of it and see what we get. Oh, actually, wait a minute. I am screwing one thing up. I do have the hard-coded width and height here of the gift that we were using. Blah 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 blah. There we go. Take these, move them up here. Fix me, move and rename these. And we'll get rid of this. Woo! Hey, Lucy the Stoink, thank you so much for the raid. Let me get you a shout out, just really quick. How'd your stream go? What were you up to? We are writing a GIF importer. Yeah, I know. For Jodot, we're actually writing a there's scripter width and height. Oh, you know what? We can actually just use the width and height from that. So we're just worried about loading one of the single sub images. Alice in Madness is a great time. Nice. Love being rated into someone that I also watch. Hi. But yeah, we're currently doing we're trying to write a GIF loader for Jodot. It's going. That doesn't look like correct data though. Let's see if we can go back to loading icon.gif. Love the model. Thanks. I made it myself, and I made the VTuber software, also in Jodot. Normally, there's another model on this stream, which we also made ourselves. But how much further you gotten from yesterday? Yeah, we're making some progress. All right, let's try to load up that Star Trek GIF. We're currently attempting to load a GIF off of an old CD full of GIFs of some Star Trek stuff. Oh my goodness, Cast Makes Games, thank you so much for the raid. I got that's a double raid. Hi. So yeah, we're okay. Right, so we were gonna print out the decompression result at the end of all that. Hopefully that actually works. Not beating the gender non-conforming tech-savvy stereotype. Yeah, well, why would I want to beat that, you know? I think it's funny. Okay, we're still not seeing the decompression results. Setting. This is probably because of the midstream. This is probably because of the midstream thing. Oh, we're not handling the midstream. No, wait, we are handling the midstream decompression or midstream clear code because just by the nature of the fact that we're splitting the stream into different things based on the clear codes. Managed to de-Google your phone? Oh, congratulations! Yeah, I started running post Marketos on a Pixel 3a XL, and so far it's been pretty nifty. I'm not sure if I could totally rely on it yet, but we'll see. So we are actually getting different indexes and stuff in here. I don't know why that's not showing up in the image. Oh, we're also getting an error. Expected image data of size blah 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 got blah 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 instead. 183.
One more time.
Valid image is empty. Interesting. It's not decoding enough stuff. Like it's missing data or something. Antonymph? Antonymph is a great song, but this is an Antonymph. Antonymph is in the playlist, but this is not Antonymph. It is Violet Pony though. Antonymph is one of my favorite songs. Yeah. Okay, you know what? What if we just like tried padding the data? Because this almost certainly has like multiple image descriptors in it, and that's what our problem is right now. So that samples all the other songs. There, that'll do it. And the name of friendship, yeah, the song name's right here on the side. So. Ooh, that hack has taken its time. Huge Violet fangirl. Violet Pony's good. Yeah, the playlist is. Oh, thank you so much for the follow. The playlist here that we have is mainly made up of, we got Violet Pony, we got like 2 albums of Violet Pony, you know, Violet Pony allows people to use music for stream stuff. So we got Machine Supremacy, and then we got Dance with the Dead. This is like the complete Machine Supremacy stream safe playlist. I wonder if they'll ever add their new album to that. That'd be cool. We got 2 Dance with the Dead albums, I think. And yeah, probably gonna pull in more stuff on there. But the Violet Pony albums we have are, with a bunch of songs removed. We have Love and Pony Step and Girls Who Are Wizards. Okay. Can we do like this times that? I guess not. What's the best way to just like expand an array? You just do like a set length or reserve or. Insert, set, slice, sort, fill. Resize, there we go. Set the size of the array, blah, 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 blah. Okay, yeah, all we gotta do is that. Decompression result dot set size? Resize, there we go. And then it's gonna be with time type. Multi-stream, yeah, we are on Onwcast. Technically also on YouTube, but I don't pay any attention to the YouTube stuff. And no one follows it over there, so it's fine. I do like Onwcast though. Oh, hey, there we go. We got something happening here. Does that look like the top of the image in this one? I think it does not. Actually, wait a minute. That's just like it's something like right in the middle of the. Or no, this is the image right here, because we're being rendered to a plane and stuff. That doesn't look like the top of the thing. Like these would all be the same palette index, I assume. It's not crashing during decoding though, and that's a good sign. So yeah, we probably just have more image descriptors to get through. Oh, wait a minute. That'd be oh, it's probably the last image descriptor. All right, let's see how many times we hit this call right here. Once. Okay, well, so much for that idea. It's got a single image inside of it. And so if we go into load image descriptor, and then I think this actually would load all the sub-image stuff. So yeah, this could be improper handling of the midstream clear code again. That's causing this. I'm not sure though. Are we getting? It looks like we're getting an end of data code early. Let's see where's the end of data. Here we go. All right, so there's our end of data, and this is the part where we're just like, where is this in the code indices? Would an internet I have plans on routing my phone in the future. Would an internet service provider be able to let that phone be covered? Yeah, I mean, why wouldn't they? People use rooted phones all the time. I have Lineage OS on one of my phones, or on multiple of my phones actually. I have Lineage OS on a phone with 2 SIM cards. They're through the same carrier, but whatever. I wonder what would happen if we just ignored the midstream clear code. That happens. Okay. So the midstream clear code is necessary. Next substream. I wonder how much data is left in the array. So we got this current bitstream contents. Oh, actually, we should check to make sure that like current bitstream contents bitstream contents. Current bitstream contents is null pointer. Oh, that's bad. That's weird. That should not be happening. I bet that's a bug with the debugger. Okay, now I'll have an idea of like how far it made it through that thing before. Yeah, I have no soul. There's no distinction in my mind. You are my enemies. Got end of data at 175,197 out of 175,199. How big is this image? Oh, this image is actually about that big. That is... So we're going through most of the data in the image. That's weird. How many midstream? Oh my god, we got a few midstream clear codes here. Codeless and codes, blah 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 blah. I wonder if result. Ah, there we go. There we go. where we're actually only using the last, yeah, we're only using the last decompression result. Why is Godot better than GameMaker or Unity? Well, Godot is free and open source, and it runs on Linux, and it's fast, and it's easy to mess around with the internals. If something's broken in it, you can send in pull requests to fix things on it, which I've done many times. GDScript is a fantastic language. Performance is decent. The people who run the project are cool. And did I mention that it's free and open source and runs on Linux and a bunch of other platforms? It's a nice little barrage of answers. The 3D features are actually pretty good. Also, it has some like it has a few real-time global illumination features that are pretty awesome. Are you fidgeting with a knife? Yes, I'm fidgeting with a knife again. Of course, I'm fidgeting with this. This is my fidget toy. I mean, I've $200-something fidget toy. Anyway, so yeah, the decompression result is wrong. Equals S before loop result, blah 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 blah, current decoding table, blah 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 blah. Evil minions back from our misery at last. We just need to say plus equals on this. Single nightmare from my memory and dreams. So we could probably get rid of this. Fix me, check to make sure this matches. Fill in stuff if not. And throw an error. Okay, we got our end of data. End of data is at the appropriate point. Good. And do we actually have... Oh, it's decoding stuff still. My fidget knife. Yeah, mine is a Benchmade Osborne 940. It's quite nice. Wow, this decoding loop takes a while. We might have to optimize this more. We're also printing out a lot of stuff to go with it. Is it correct? I don't know yet. Yeah, the actual LZW decompression, once we have the codes, like the LZW decompression still takes a while. This is not a fast decompression algorithm when implemented like this in GDScript. We could probably, okay, so we could probably like shave off some time. This is I think this is right here is where the bulk of the performance is getting lost. We could probably shave off some time by having decompression result be pre-filled instead of appending it to the array the entire time. The decoding table, we could probably use an array that's like pre-filled to a specific size. So we don't have to like append to the array all the time, because we are appending to the, right now we're using a table and we're appending to that table a lot. to get this done. Every single time we go through and we add, every time we do a single pixel, we add something to the decoding table, and it's a dictionary right now, so it's like a dictionary lookup when it could just be a flat array lookup. So we're definitely losing time from that. I want to just verify that everything is correct before I actually before I actually bite the bullet on making those optimizations, though. Sorry, I'm fidgeting with the knife again. It's just so much fun to fidget with. That's taking a really long time to decompress. I'm getting concerned. Look at this, like, before loop result. This is the last thing it prints before it goes into the decoding loop here. And that's what we're seeing, like, right before it has, like, a big pause, you know? So we apparently have a lot of midstream clear codes. I would be willing to bet that we have a midstream clear code per, like a midstream clear code per, scan line. I bet that's probably what they're doing. How big is the image? It is this big. 640 by 480 pixels. Space City Graphics. There's the name of the BBS that you can go to dial into in order to download this GIF. Specializing in sci-fi fantasy GIFs. Notice that this GIF is not animated, also. 9600 baud. Well, I take comfort in the fact that we're probably decoding it faster than they downloaded it back then. The file is, hang on, let's actually do the math here. The file is 172.6 times 1024 bytes. So divide that by 9600 baud, which is bits, so we're dividing by 8 there. And we would have, nope, actually we are decoding slower than it would download. Yep, it would have taken a couple of minutes, a couple of minutes and some change to download this GIF. Hey Shar, we're attempting to decode Star Trek GIFs, which looks like this is not actually just like a snapshot from the show. It looks like someone actually went in and added a bunch of like little lights and stuff all over the place on this GIF. They manually like made it look. They manually touched up this GIF. I think the decoding might be alright. It's definitely unoptimized. The way that we're using a dictionary instead of an array is definitely not good. So I still suspect that we're probably using I have a feeling that we're probably doing yeah, so like I said, we're probably doing like a single clear code per scan. Oh wait, hello, hold up. What do we got? Hey, look at that! The aspect ratio is a little bit odd, and the text might be missing from the top and bottom. The aspect ratio is wrong because we're actually like sticking it onto a square plane. That's fine. So the aspect ratio, we're not concerned about. I'm gonna copy this to the clipboard. We're gonna open up Krita. I bet what we're seeing on these on the edges, the reason that we're not seeing the text is probably because those palette indices are too close and we're not actually decoding the palette yet. It is thankful that, again, the palette indices seem to be sorted on the actual photo part. Yeah, there we go. I can see the text. The actual palette indices on the photo at least appear to be sorted by luminance, which means that we can actually see stuff. Is it supposed to be red? These are palette indexes, or indices. Let me open this up in the GNU image manipulation program. yeah, so here's what our image looks like in the GNU image manipulation program. You can see the GIF palette over here. You can see that it is sorted by luminance. So what this is doing to output here is it's outputting to the red channel what the palette index is. And so basically lower red means closer to the start of the palette, which is black, and higher red means closer to the end of the palette, which is a lighter color. The fact that it's sorted by luminance lets it appear like this, because this table, if this weren't sorted by luminance, this would look like gibberish. But it is sorted by luminance, and so we got something that looks correct. However, the part where they added the text to it is not sorted by luminance. But we can still see differences in those in the palette indices for those. So this is basically, I just haven't implemented the actual palette like lookup yet, which is really, really easy to do. So the unfortunately named image manipulation program. Yes, there's a reason that I say out I say the entire name every time I anyway, with a little bit of tiny bit of tweaking in Krita, we can very easily see the original text pop back up there. And that's like I said, because those pixels are just like in the palette really close together. So someone took a GIF of Star Trek with the palette already sorted by luminance, and then they added this border around it by probably just appending something to the starter end of the palette. GNU image manipulation program is a mouthful. Yeah, it is. Oh, Kiri, hey, hello, thank you so much for the raid. Yeah, we're just showing the palette index right now. Let me get you that shout out. There you go. So yeah, we are successfully loading the entire image. We're just not doing the palette lookup yet. But hi, Kiri. We're doing how did your stream go? What were you up to? And we are currently working on GIF decoding. I'm writing a GIF decoder in GDScript for fun. So we've written our own like LZW decompression code, our own like bitstream decoder, a bunch of like it's been a whole thing. Did some Doom? Nice. Okay, we're gonna commit what we have here. Which is... I'm gonna add all those Star Trek GIFs to the repository. Added test data. Added test uppercase data because some of the images are of data. Get it? Get it? Whatever. We're using a bunch of Star Trek GIFs as test data. I found like this does not add anything to the image. This is not funny. This is like there's that period of time where like people would take like an image with a joke and then they would like add another thing onto it to be like, haha, so funny, look at the thing with the stuff. Someone thought it was funny? Yeah, I guess. Someone did. Sure. That's interesting right there. It almost looks like it's been... Oh, this... Wait, hold on. That's not green screen artifacts. That is... Someone actually, like... Someone actually cut this out. Like, on the GIF. Ooh, and they did a bad job of it, too. People still do that with the social media captions. Look, let me have a little bit of faith in humanity, okay? You don't have to take it away from me the moment I expose it, okay? All right? The movie BBS. 12 or 2400 baud. Oh my god. Oh yeah, no problem. Probably got lost in some of the raids that we've been getting. Wait. File name Vulcan GL. Wait, hold on, isn't that a Romulan character? Whatever. Anyway, we got gifts. This is our test data. Need to know I'm awake and remembering our time. We could go ahead and we could go two directions now. We could go ahead and implement the palette decoding, which would make the images actually work, or we could try to optimize the decoding table. I think it's probably a good idea to optimize the decoding stuff, because right now it is a bit of a mess. The reset table function itself is probably like too expensive. And we call that function a lot. I wonder if there's any way that we could just like get rid of the bottom of the table. I think optimizing the decoding would make further testing faster. Yeah, I think you're right. So yeah, let's check out everywhere that we reference current decoding table. We reference it in a few places. It's currently a dictionary. We keep track of the position in it. We wouldn't have to keep track of the position in it anymore, which is kind of fun. Because then we would just be using the length of the decoding table as the position. And I think the only time that we actually use that is... Anyway, I did a code check-in just now for a reason, so... Pretend with me, what we once were, we will return, sky, earth, and in between. Come march with me as our world burns. Okay, alright, we're gonna change it to an array. We're just gonna rename it as we do this, and then like all the uses of it will immediately become invalid. And this is also going to be a packed byte array, because that'll probably be faster than a normal array. Why do I have semicolons here? Oh my god. Okay, so we're going to reset this to an empty array. Actually, we'll just packed. Actually, no, I have a better idea. We'll just reset it down to the max code size. We'll have a separate function for initializing the table. Oh no, it's a packed. Wait, hold on. Crap, we can't use packed byte array. We have to use. We actually have to have an array, because we're actually storing like sequences inside the array. Crap, I forgot. Yeah. Okay, so we're gonna call. We have init table, and we're gonna call. I'm just gonna short this to init table right now. So, but later on, we're gonna do this, right? After I get the after I get everything working again, we're gonna do that. I guess also we should go ahead and we need to add the 2 entries for the clear code. Make room for clear code. Make room for EOD. Okay, and then there we set the position. Guess we'll do, this is gonna be max code size. Actually, wait, hold on. We can do max code size +2 and then say, I'm just gonna call this a placeholder for clear code, and placeholder for EOD. Clear code more like clean code? Oh no, we don't have any of that here. Not a chance. Okay, I'm gonna comment that out for now. We'll actually put init table max code size in here somewhere. But this way, we only have to initialize the table once, and then all we got to do is resize back to that max code size +2. So we're just gonna like cut off everything past that point. Yeah, that looks good. That looks good. We don't have. Oops. Okay. And then we're gonna say init table, LGW minimum code size, and we're gonna put that right here above the thing. So it's only gonna do this once per image descriptor now, and then reset table should do that, and then say array, fix me add bounds check. Do error handling, which is basically just a rephrasing of what we got right here. Okay, so here we have to change this up a little bit so that if next code less than or equal to length of current decoding table array.
You will always be a monster.
Oh yeah, we were gonna like pre-allocate the size of it, weren't we? We'll have to keep a pointer. I don't like the idea of like constantly deallocating and re-adding stuff. That's whatever. We'll deal with that optimization when we get there. Why do I keep adding semicolons to stuff? Oh my god. Fix me. Don't append, just fill existing space. Okay, well that looks like that should be good. We do have a current decoding table position, and so we could just use that. Right? Yeah, we could just use that. Okay, that's fine. This is not fine. Invalid access of index, blah blah blah, and base object of type array. Alright, I screwed something up. I think I know what I screwed up. The current decoding table position actually needs to be... Wait, no. Current decoding... Where the hell does current decoding table position actually set? Oh, wait a minute. Been around, I've been a player. I've seen the world through the eyes of the slayer. So many lives, so many places I've been since the first time I tasted. Oh, current table decoding position isn't actually used anywhere. Like we set it, we increment it, and then we assert with it. But we're not even hitting that assert yet. So yeah, this ain't working. Actually, wait a minute. Hold on a second. Hold up. Wait, how are we... What? Okay. If next code is less than or equal to the length of current decoding table array, then S equals... That's where it hits the thing. What? Oh, wait. I'm a dum-dum. It's going a little tiny bit faster now. I think all the appending and removing on the array is actually like the hard part. So I think we're going to use that current position thing on there. But yeah, let's see if the decoding actually still works. Because if it does, then we're still good. And we can keep going with more optimizations. It is actually instantiating probably a whole lot of arrays as it does this. Because every time it adds something, then it's gonna... Oh, yeah, every time it adds something to the array, it's gonna instantiate a new array that's a copy of, like, some old arrays plus some stuff. So in retrospect, Jodot's, like, built-in, yeah, Jodot's built-in, like, array handling... Probably not a good fit for this stuff. Unfortunately. We're gonna have to try to optimize the crap out of this. How can we do this? How can we just make sure... I think it's probably gonna come down to like allocations and stuff still. Allocations and deallocations. So, like, how are we going to minimize the number of allocations that we're doing? We could write our own heap that we pre-allocate. That would be a lot. That'd be a lot to do. We could... It's like, I wish I could just have like an array that we could just like make, like a massive array that we could just like make slices of and stuff. No, I don't, using the built-in like array stuff in Jodot. I'm not sure if there's an easy way to avoid like lots of reallocations. Wonder how big these wonder how big the strings actually end up in the dictionary. Like if we could just pre-allocate like a bunch of them at like the max size, maybe that would be okay. And then just reuse those throughout the entire thing. We'd have to make, you know, we'd have to make a lot of them. And just the allocation of that might be a lot. I can think of about a million different ways to write this a lot faster in C, but we're not using C here. We could have like one really big array that we write data into and just like pick slices out of that, but that's still doing an allocation every time we want to get the slice. Because it's going to be copying it out of there. We could, well, we don't have to necessarily take a slice out of it. We could just kind of do that stuff manually too. We could have like one really big array for the table, and maybe one really big array for like where in the table things actually start. That'd be a really complicated way of doing that, though. Sorry, I'm playing with my knife again. Meanwhile, Thor is taking a bath. We did get rid of all the dictionaries, at least. We are still appending to the array every time. And so I bet that's probably like the biggest source of our allocations problem. But we actually do have that pointer that we just like added the assertion for. We could actually just make it so that it only allocates, like, adds to the allocation if the length is not big enough. No religion, no real place. I grow weary of these walls, so tired of it all. Dull gray and endless days, here where evil has no face. It is hidden from my eyes, unseen or in disguise. Welcome to a world. Okay, so it's still correct on the decoding. Let's go ahead and commit what we got. Git commit -m converting to stuff. Converting to stuff. Converting to array from dictionary towards the sky. Now I feel like that again. I keep coming back for more. So reallocating the array is probably like a big deal because we're probably having to move the array contents every single time we do that, and that array is getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. That array also owns all of the data that's inside of it. To this space, no religion, no real place. I grow weary of these walls. So instead of reset table, we're gonna do this. We're gonna say current decoding table position equals the thing that we set it to in current decoding table position. I wanna play until I die, don't wanna lose my reason why. So we're just gonna be doing this. We're not actually gonna be resetting the table each time. Now we are going to we're gonna check to see if the length of this is less than or equal to the current table decoding position, and if it is, then we're just going to set it directly. Actually, wait, no, greater than current. Yeah, okay. Equals old code plus C. We're doing another allocation here, but it's not as big of an allocation. Otherwise, we'll append to the array. Okay, that should save us a whole lot of allocations. Hopefully it works. Nope, it doesn't. Not declared in the current scope. Okay, and then we get rid of this assertion because it's no longer valid. I will be here. That's a little tiny bit faster. The debugger, the profiler only works if you're actually getting frames. That's unfortunate. Is it actually faster? I can't really tell. We're next code in codeless.slice what? Wait, what? That. Okay, well that's probably bad. I'm just gonna stop you right here. Var code list slice equals that. That is of type array. Array of int. Okay, so constantly reslicing the code list probably was a bad idea. What's code list? Trying to assign an array of type array to a value of type array int. Code list, code list, code list, code list, code list. Let's try this. So codes, unfortunately, we can't declare that as a like an array of ints. What if we do? In 32 array, will that automatically convert? No. Oh, wait. Still slow. Still too slow. What if we should? I wonder if we should take timing values from this to actually see how long this is going to take. Let's see how many codes we're actually processing. 3,000 codes? We should be able to do that a lot faster than this. A lot faster than this. Just don't know. Normally, like, branching like this is... If I were writing this at a really, really low level, branching like this would be a big no-no for me. Right now, I don't know. Anything that avoids anything that avoids like more allocations. Maybe we can cache the value for len current decoding table array. Something tells me that's probably not the really expensive part of this. So here it's appending a couple of things together. I wonder if we could keep track of the max length. If there's like a way to reserve. Come on, reserve. There is like a reserve space in some of these structures, but like not the array type. So yeah, we're gonna get max code length, and we're gonna add that right. So yeah, we'll see at the end of this what the actual maximum code length is at the end of each. There we go. Print max code length. I bet this is probably gonna be pretty big. Okay. Invalid operands, packed byte array, and array in operator plus. Current decoding table array. Needs to be an array of packed byte arrays. Hey, Viper. Oh, right, that is wrong. Let's try that. And pulled into a night world. Impression results. Packed byte array. Changing everything to packed byte array is probably... Oh, hey! Oh, hell yeah! No, it didn't work. It was so fast, though! Frick. But it was so fast! It just didn't work! Alright, what did we change? Flop. Yeah, so that's a problem. But if we can actually get that speed out of it, then we're in good shape. We just have to fix the bug. We actually have like a bunch of data in the decompression results, which is encouraging. But it didn't get enough bytes from the decompression. So let's. I'm gonna throw my hack back in here. Let's see how close that we got. Okay. Yeah, that leaves a bit to be desired. It doesn't have to work. I can write a version that executes faster than the input hardware. I think we're getting close, though. This is actually an encouraging result. You can look at this. It actually worked for the top little bit of it. And then something went off the rails. So what happened at that moment? Like, it's kind of the question. So what did we change just besides... It was still working before we changed the types, right? If we change everything back to array, will it start working again, is the question. So yeah, in the process of like converting stuff over, I think we screwed something up. This is... Alright, I'm gonna hit the undo button until we're back to working again. Try this. Also, let's see where we are on our diff. Because I think I may have made an incorrect assumption that this is working and stopped it early. But it seems like, you know, if we get this back to a working condition, and then we just switched over to packed byte array, we might actually be good to go. So I could just revert back to... Oh, wait a minute. Yeah, I could just revert back to the last functioning code and then do that change while ignoring like the rest of whatever is going on in here. You know, this stuff. Because we were doing a bunch of stuff to like, you know, get it down to just individual slice, figure out the deallocation and allocation stuff, the slices and all that. So yeah, let's see if this works first. If it does, then we can commit and figure out about re-adding the packed byte array optimization, which seemed to work very well. I think that's actually like moving this into the realm of possibly going to be a thing, because like right now the decoding is painfully slow. I wonder if we're better or worse than the 9600 baud stuff now. Let's see what other images we can. There's a swimsuit directory. We are not going to be looking at that one. Technology without an O is a directory on here. Oops, that's don't look at that. Okay, there's nothing bad in there. Great. Just opened it up in the wrong thing. Oh baby. Oh nope, that's a penis. That's a penis. Yep, there's a GIF of some like anatomy diagrams, and that's a penis in the technology directory. That's highly unfortunate. I wanted to use the technology directory because there's some delicious looking stuff in here. They got a picture of an IBM mod. Wait, that's not a Model M. That's in. So there's a picture of a Model M here. Look at this. There's a picture of a Model M, but that's an AT&T branding on it. Weird. Hottest 286 PC in the business. Aw yeah, best of 1987. Got some renders. Now notice how everything just looks better on the Amiga. Like look at this. Look at this. This is actual stuff from like the 80s, right? This isn't just like something stylized to look like it's from the 80s. This is actually from the 80s. Holy crap. That looks that color palette, like the shading and everything. This looks damn good. Look at the dithering on that. This is beautiful. This is where Amiga was when IBM PCs were not there. IBM PCs at the same time. Look at that EGA color palette. Aw, yeah. This thing done yet? Yeah, booting up the system. Get it? Because he's kicking it. Bulb. It took how long for the PC market to discover the wonders of square pixels? Oh boy. Yeah. What is this? Cold fusion experiment. Wait, this isn't fusion. This is combustion. I think you can find both heavy water and palladium. This experiment should only be attempted by qualified chemists and physicists. They're doing electrolysis, okay? One small explosion from a minor glass breakage. Probably because someone lit the hydrogen. Okay, so it's still broken. So let's I think we're just gonna go ahead and now that we're looking at this diff, we can actually tell where we probably screwed up. And that was probably how we're resetting the current table position. But this is a really good optimization, though. Why is it screwing up? I like this. Computers are not the reliable boon we all had hoped to see. They're only half as efficient as they really could be. The glitch is not in the microchip or the complex electronic circuitry. It's a simple short between the ears of operators like you and me. Relevant for today's world. Arizona, I wanna be alive. I want to live. I wanna be alive. Make high-density discs from double-density discs. This is sketchy. This is sketchy at best. It would make it treat a double-density disc as a high-density disc, but I don't know if that would actually... We got valves and camshaft and spark plugs for some reason. Oh, it's DOHC, dual overhead cam.gif. Nice. Got some like EGA graphics stuff in here. It's a EGA funct.gif. Looks like something to do with EGA hardware. EGA functional diagram. That's how they made the USB sticks you ordered. Yeah. More like fusion stuff. Someone was really interested in like cold fusion, I guess. That goes to show how long the scientists have been pursuing that one. Oh yeah, check this out. Advanced modes. 1024 by 768 with 16 colors. Interlaced or non-interlaced. 800 by 600 256 colors, and 640 by 480 at 256 colors. Hell yeah. Ancient ass GPU. Let's see. This is actually an interesting like little GIF test. That's kind of cool. I think I recognize that one. What else we got here? Anyway, we gotta go and undo our optimizations. Feels bad. What if we actually just set reset table back instead of setting the current decoding table position, and then just like left everything else? Like this is probably fine. That's just insertion, and then yeah, this is the part where it's overwriting the table. But in this case, it's always going to be Yeah, we'll get rid of that optimization too. Yeah, for reals. Anyway, where were we? Oh, no, I didn't close the window, did I? Yeah. Let's go to a different category. Oh, ray trace. Oh, that's boobs. Damn it. I'm still gonna look at it off stream. Yep. Oh, yeah, that's boobs. Reptiles. Nope. Nope. Don't look at that there. Yeah, this CD just is like does not distinguish between this stuff that's like full of new. There's naked women in the reptiles category. There's so much porn. It's not like porn, it's just a naked woman with the snake. It's just good thing Star Trek stuff is at least safe for work. Oh, we got some Robotech. That is a I believe that is a oh, that's a Legios. Nice. Yeah, well, I don't want to show them on stream, like let me bring up like what this is supposed to look like. This is the Legios from Mospeada. And this is the Alpha Fighter. This, I think, I might be getting this wrong actually. From an upcoming cyber animation. But you can see the like the weird intake boobs are cylindrical here. You can see the shape of the head is kind of similar. They were definitely like making up a lot of stuff as they went. This intake right here, or actually I think it's one of the VTOL like outputs for the VTOL mode. I think this might be also is actually on here. So these are trying to be the same thing. It's kind of like it looks like a mix actually of some elements of the Valkyrie from Macross and the Legios from Mospeada. So in the world of Robotech, that makes a lot of sense because this would be an extension of the Valkyrie design in that universe. In Mospeada, it's not. Oh, there's more boobs. Skipping past that. A vegan advanced fighter engages 2 Amalgam cruisers. Is this what they call militant veganism? Sorry. Oh, hey, there's the Legios. That's a transform mode of that one. Is this thing working yet? Damn it. We got some bubblegum crisis. Nice, always good. Some Blade Runner gifts. We got some Star Trek mixed in with the sci-fi category. We got Colossus. More Star Trek stuff. A lot of seemingly broken images. Oh, we got more Mosquito stuff. So this is in Robotech this would have been an Invid. And this is the this would be the Cyclone motorcycle. In Mosquito, I think this is the Mosquito thing that they're talking about, and they're called the Inbit in that one. Same with this one. There's a lot of Mosquito stuff in here. Nice. There's also some Doctor Who stuff. Lots of Doctor Who stuff. Yep. We got some Gundam. Some custom Gundam, I think. I don't know if that's a real Gundam. Yeah, that's the weird giant border on it. More Doctor Who. Good heavens. There's a lot of... Okay, this one, I've seen an animated version of this one. There's a... This is supposed to be animated with, like, palette cycling stuff. I actually have one of these as a test image for my LBM importer. We got some Macross Zentradi battle armor. We got an actual Valkyrie. Skull Squadron thing. What is there? Wait, hold on. I don't recognize this gun up here. Did they add a gun to it? Interesting. Gripper looks very squimshed. Oh, is this thing done yet? Okay, we're back to working. So we found the bug. It was in this stuff. So I think we can go ahead and re-implement our packed byte array optimizations now. And then maybe we'll go back to making it so that it doesn't reallocate or like constantly reallocate the thing. Actually, no, I want to make it. Dang it. Yeah, we should do that. The packed byte array optimizations actually had like speed, right? So let's go ahead and it's a bad commit message. I know. I'm a terrible person. Okay, so the packed byte array optimizations. Let's get those all back in. So everywhere it says array like this, it's going to be a packed... Wait, no, it's an array of packed byte arrays. Packed byte array. And then everything's going to break. So this is fine, current decoding table plus C, as long as C and the other one is packed byte array, and S. And decompression result also needs to be a packed byte array. Okay, is this gonna work faster? Yes! Wow! Wow, did you just see that? Hold on. Let's do that again. Bam! Holy crap! That is so much faster now! That one optimization just holy crap. It's still not perfect. Switch to a packed bytes array and got a lot of speed. Okay, but we can do better. We can do better because right now we're missing stuff in the encoding stage, or in the stage that goes right before that, I think. What is this? This thing that's printing out. Is that printing out the decompression result? Okay, so that's printing out all the codes. We can skip that and just get boop. So we can still see that it's taken a little bit. It's taken a little bit to decode it, and so we can probably fix those by doing more packed array type optimizations. I still want to get the reset table thing back in though. So now that we've done all that, let's see if we can get this one back in right here. Okay, that's still good, but it's also never hitting this case right here. So we might still be wrong there, right? So it's a combination of that and this. That broke it earlier. Right. Now we're hitting that case repeatedly. And we're getting a bad result. Now we're failing to decompress properly. Let's add that assertion back in. No, actually, no, wait. Right, that has to take on. Okay, so this must just be off by 1. Current decoding table position. So in reset, actually, wait. If we bring back the reset thing, then that'll be fine. Unless, oh, do we? Oh, wait, no, I'm doing something really silly there, aren't I? No, I'm not. No, that's fine. Okay. It's setting it, not reading it. I thought it was reading it for a second. What else do we do in the reset table? We resize the table, of course. You know, I'm just going to take this out, and we're going to move that down into this code. Okay, now we don't need that function call anymore. Yeah. Should be back to working. We are. Good. Okay, so this should be like a really, really simple thing to figure out now, because... and we aren't hitting this case at all. Right. Is the size wrong? No. We should just be able to get rid of this and have it work. No longer resizing. But it's not. What is the actual difference between keeping track of this pointer? Keeping track of this pointer and... Actually, I guess we should be able to... Like, you can see what we're doing here, right? Y'all can see? Right? Maybe? Maybe not? I don't know. We're trying to just get away with not reallocating the table all the time. And so, like, deleting the table... As long as we're, like, adding to the table, everything's fine. But once we start... I think I know what I can do for this. Our fix me temp table equals current coding table array dot duplicate. So now we're gonna have this fix me temp table. This one's not going to this one's not going to resize down. And it should always remain the same. Yeah, it should always remain the same up through current decoding table position. We're just gonna do the same things to it. Except we're going to treat it a little bit different. We're only going to append to the other one. So we're going to take this out of here and do that. Like that. We're going to get rid of this. Here I wanna be another face in the masquerade. Okay, so one of these is getting the new thing done on it, the other one's getting the old thing done on it, and then we should always be able to assert that that slice 0 through current table decoding position -1. And that should always equal the other one. So we've got our sanity check. Now it's going to take forever again because we're doing some nasty array copying and stuff. Actually, wait, why is that taking so long? This is like a really minor bug. This is really just like we could like wrap the array thing up in a thing that just keeps track of like the capacity versus the actual size, and then it would probably be okay. Face in the masquerade. You really wanna be another face in the masquerade. Why did it work this time? Oh. Right, there it is. Found it! Found the bug! Found the bug. Yeah, we're gonna do current table position. Let's get rid of this assert. And actually no, we'll keep that assert. For funsies. Let's look at some other silly gifs. Oh, there's a directory here called hunks, which contains exactly what you think it does. We also got fractals. Fractals are cool. I like fractals. Alright, image still works. Let's go ahead and just add this back in and see how it do. That's a failure. That's so weird. That's really weird. Hold on. Wait. 258 is out of bounds for current decoding table array, but that's the size that we set on that. And these both go up at the same time. Oh. Nope, that's still wrong. That's why are these two things growing separately? Why are these two things growing differently from each other? Assert len no. You ever feel like you're getting gaslighted by your own code? Gaslit, rather. Whatever. That assertion has failed. How did that assertion fail? These are both wait, what? These should both be behaving exactly the same now. Oh, they're not, because this is resizing. This is gonna break it. Maybe this is a bad approach to use. This is probably the incorrect, like the wrong approach. Crap. How is it? Wait, hold on. No, it is still growing at the same. It should still be growing at the same. Oh wait, we need to split it that if. So that yeah, okay. I'm a dum-dum. I think I know what's wrong there. This is going to not work anyway. Yeah, this needs to be split up into two separate things. They should both be behaving exactly the same this time. I might just have to revert back to the previous thing that we had. Oh, back to the gifts. Hi, Thor. Hi, buddy. Wait, were you just... Oh, we got a bunch of ones from movies. That's definitely gonna have boobs in them. Oh. Oh, hey, the thing's working. Nice. Wait. The thing is working and we're not resizing the array anymore. which means that we can probably get rid of all the fix me temp stuff. Okay. Git commit, git status, git commit -a-m. It's working, but I don't know why. That sounds good. Great commit message. Let's do that, and that. And this should go back to being fast again, I think. Oh yeah, there we go. Okay, we got our optimization back. So we got our packed, yeah, the speed boost from our packed byte array optimization is back. We have disabled the temporary code, and I think... Shoot. Yeah, buddy, it's just a mouse. I'm sorry. That apparently scared the heck out of Thor. Me dropping my mouse. Okay, let's get rid of the print statements here. And the part where it prints decompression results. Yeah, so there's still a little bit of there's a moment there, bloop, between when it gets the EOD and when it actually has the image ready to go. This might be about as fast as we're gonna get this, though, unfortunately. We've already, like, removed the extra allocations. We've converted everything to packed arrays. All in all, we made a whole lot of progress today, though. We got that image working, and we optimized, so I feel pretty good about this. I feel pretty good. What's current bitstream contents? That we could probably optimize. Yeah, that's going to be a packed byte array. Packed bytes array. Fix me. Instead of this being a while loop, this should just error out. Let me hit this condition. I feel very good about this. Should we write something? Should we make something that actually writes GIFs now? Okay, actually, let's do the let's get the palette in. Let's see, process file. Where's the GCT palette? Palette is an array of color. Load image descriptor palette. We're still ways off from doing like animated GIFs and stuff like that, but I really just like, I really wanted to get the LZW stuff, decompression stuff down. So okay, so we got the decompression result. So we're gonna make a new, how do we, what's the image format? Blah 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 blah. Wonder if we can just give it an array of color values. Format. Straight from data, format is a packed byte. Or oh, okay. I just want to make like a thing of colors, because that's what we have already. All right, we're gonna use format RGB8. We'll use that palette. This is gonna be a little bit messy. So var im data equals packed byte array. And I think, can we do, yeah, we'll just do that. Packed byte array. And then we'll image data dot resize. It's gonna be width times height times 4. We're gonna use RGBA. So Jodot does not support GIF files natively. It supports like PNG, TGA, a whole bunch of other formats, but for some reason it doesn't support GIFs. Now I use, for my stream overlays, I use a bunch of Jodot stuff. So we have the intro funsies, which are still running. Anyone who wants to play around with that right now, you know. If I just spam chat with the emotes, they pop up in the intro funsies, and they bounce around for a bit. The problem is I can't load animated GIFs. So if you use anything with a GIF, it just gets replaced with a pride flag. So yeah, only non-animated emotes work with this. I want to be able to use animated emotes. So that's why we're doing this. There is a GD extension add-on that'll let you do it, but I'm not going to use that because I'm too cool. And I wanted to write my own in GD script. And then we're going to go on to writing our own LBM and PCX importer, possibly, if we get this working. Yeah, you can see that didn't work. So here, I'll just... spam the chat with tails, and all you get is more pride flags into the intro funsies. Which is fine. Pride flags... I need to add a poly pride flag to that. We got that void punk pride flag. We can definitely add the poly pride flag to it. Okay. Alright. Okay, and range 0 through width times height. Image data, k times 4 equals C, which is type color, is going to be image. Wait. Decompression results. Okay, but it's going to be the palette. I'm going to look that up in the palette. And decompression result K, image data blah 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 equals C dot R. It's like a 2 RGBA 32. Ooh, 2 RGBA 32. It's actually what we want to do. We're going to make this a packed. Oh no, we have to use packed byte array still. Yeah, it's not gonna work. Damn. See to R8. Ooh, R8. Wait a minute. Is that like an 8-bit version of it? Yeah. Okay. Cool. Okay, VAG, and then we're gonna put 255 temporarily for the alpha, because I don't remember what we did for the transparent color that the gifts have. And then we are going to say, oops. Our GBA 8, and it's going to be the image data. All right, we should actually have color now. Not quite. Not quite. We're close. Looks like we got maybe the blue and green swapped.
Darkness devours the sky. As we near the last hour, we wait.
Which is really weird. There we go. There we go. That's the correct colors. So yeah, look, we're loading the gifts with colors now. Nice. So it's generic and can be applied widely? Yeah, sure. Animated GIFs ideally should be able to be imported as a sprite frames object, which is something that we can use for animated sprites in characters and stuff. Though why you would use GIF these days to make game assets is kind of beyond me. But yeah, you could do that if you really wanted to. Congratulations on colors. Yeah, thanks. Yeah, I'm excited. Now the real question is, if we just like throw it at that entire directory, will it actually work, or will it start crashing? I bet some of those GIFs that it's not. I bet some of those GIFs that fail to load are also gonna have failures in our thing. All right, this is just gonna go through like all of them and immediately fail. Can I get method buffer on a null value? Oh, I forgot to use use process directory, not process file. Process dir. So yeah, there's a failure. Which file are we on? Debugger, stack trace, process file. I bet this is going to be one of the ones with an encoding issue. 3D Trek.gif. Oh no, that one actually was working for us. This one. So we got some weird encoding issues going on here. That's interesting. Out of bounds index, blah blah blah, unpacked byte array. Which is really weird that it's hitting that one. We got two bad codes right in a row. Let's try that. Okay, yeah, that's not gonna work. So we're getting some codes before we've actually like had a chance to decode them, and I think there's a case. I think this is a weird case that GIFs can run into. Oh, we're over time. I gotta wrap up. Let's figure out someone to raid and let's get the heck out of here. Bridgewater has redeemed a... I can't leave without my buddy Superfly! Come on, Twitch. Come on. Let's go. Come on. Load the page. Well, no problem, Kiri. I know who we're gonna raid. This is a rare treat. Excellent. Okay. All right, I'm excited. We're gonna raid the official Twitch channel of one of my former employers. I think you all know where we're going with this. Let me get the raid message up. Snack raid. All right, there is your raid message. And I'm done with my ad. And copy it out of here. And we're gonna paste it in here. Copy that again. Yep. Let's see what they're actually up to right now. Talking about some Star Trek Online stuff. And of course we have to sit through an ad, but all right. Well, thank you everyone for joining me for another Weekday Morning Art / Dev stream. Is that a rally fighter? Really appreciate having y'all here. You're all awesome and amazing. Hope to see you next time. Take it easy, take care, be kind, show compassion, show empathy. Don't get in a knife fight. Use containers, and stay safe. I'm just gonna wait until the ad's done so I can actually hear what they're saying. When we kick off the raid. All right, there we go. Have a good one, everyone. Bye. You're all awesome.